So we have to find the force in each member of this given truss. Okay, we have a figure of a truss which is hinged at one point, and there's a roller hinge and normal hinge in one side of this truss AD. At point A it is hinged, and at point D it is roller hinge, and we have two force downwards, 10 kilonewton, each of 10 kilonewton is acting downward at point C and B, and there's a 2 meter length. Okay, that side AB is given, as well as AD is of 2 meter each. So we have to find the force in each member. Let's look at how to solve this problem. So before solving the problem, we have to, we should know the basic angle just by looking at it. Okay, if you look at the structure of the stress, you can assume that angle ADC is 45 degree, as well as angle DAC is 45 degree, angle BAC is 45 degree, angle ABC is 45 degree. Okay, because if you just complete this whole truss, suppose you extend from D, a line is extended from D to right side, and similarly from B downward, it would intersect at a point, right? If you look at the whole, it would be a square. So from that perspective, you can know that is whole angle 90 degrees, so the half will be 45 degree. So you should analyze that from the figure. Okay, it will not be given the question, but you should be able to decode from that given figure. Okay, so the very first step is you have to find the reaction force at point A and D. There will be a reaction force right at point A and D because it is hinged at that 2 points A and D. So there will be a reaction force. If I assume, suppose I am taking reaction at there will be at point A, there will be a vertical reaction or some reaction because it's a normal hinge support, and for roller there will be only a vertical with respect to the roller. That means for this figure it will be in the horizontal direction. Okay, so this there will be a reaction at this hinged point A and D. So the first step is you have to find that point, right? So I will be taking moment because this whole thing is an equilibrium. So the basic law principle of equilibrium law of mechanics is the force is at equilibrium as well as moment about that point will be zero. Okay, I will be taking that principle. So I will be taking about point A. So we know if I am taking about point A, the reaction at that point will not be taken. So I will be getting the other force, right? So RD will be getting, because there will not be any distance with respect to point A, so we can't get RA. We will be getting the other term. So I am taking about point A. So first is there's a reaction force, we know it. It is 2 meter distance from the point A, right? So and with respect to point A, the reaction will be in anti-clockwise direction. So I will be taking in one side of that equation, that is it is written 2 into RD. Okay. Next forces are 10 kilonewton each is hanging from point C and B. So from point C we will be having a perpendicular distance of 1 meter from point B, because I will be, suppose I am extending that force backward, it will intersect at the exact middle of the link AB. Okay, that member AB. So the perpendicular distance with the force hanging on the point C to the point A is 1 meter. So 10 into 1 and will be in clockwise direction with the point A. So I should write in the other side of the equation. And similarly, the point 10 kilonewton at point B, which is having a distance of 2 meter. Okay, that's the only difference. Okay, distance will be changing, and it is also right in the right hand side because it is also in the clockwise direction with respect to point A. And so okay, from that equation I get RD as 50 kilonewton. So not to be the whole thing, it to be equilibrium, right? If I look at that, only there is a vertical force of 10 kilonewton at point C and B, but there is no other force in the horizontal direction, external force. So if I am taking in reaction, it should be in equilibrium to each other, right? So the reaction is caused by point A and D. So I get a reaction at point D as 15 kilonewton. So the thing is, the same the force of same magnitude but opposite direction should act at the point A, not to be that horizontal reaction to be in equilibrium, right? So the force reaction force at the point A would be minus 50 kilonewton. Okay, basically one is compression tension, you don't take that in consideration. I'm saying that to know, okay, just to know that the basic principle by taking the reaction. So from that equilibrium of reaction, it will be an opposite force of same magnitude but opposite direction acting at point A. So it will be minus 15 kilonewton. So we will be only taking consideration of magnitude, not direction is not taken into consideration, but we should know it. And also vertical reaction, there will be a 10 kilonewton, 10 kilonewton downward. Total of 20 will be acting downward because this external force of 10, each 10 is acting downward. So total 20 should be in upward direction to be in equilibrium, right? So the vertical reaction, we know only one the vertical reaction is caused by the at point A because it only has horizontal vertical reaction. Rotor only have one reaction, so that vertical reaction should be equal to the sum of 10 plus 10, right? Only then it should be in equilibrium. So that simply we have to take the forces in each direction to be in equilibrium. Simple as that. Okay, same just like we take in normal forces equilibrium, we have to take same case for to apply equilibrium to reaction force, right? So we got horizontal reaction and vertical reaction as same value, but it will be in opposite direction. Okay, next, how to find the force in each member. For that you have to use a method of joints. So at point D, we know there is an angle of 45 degree, right? Angle ADC is 45 degree. Or the other part, if we complete this whole figure, there will be another side, right? It is also 45 degree because it is equally symmetrical. So suppose I am taking ADC as 45 degree, I know FBD sine 45. Okay, sine 45 will be, cos 45 will be the adjacent part, right? It will be in the upward direction, but if I take sine 45, it will be in the horizontal direction. That sine 45 should be equal to that horizontal reaction 50 kilonewton, right? Because that's the only reaction force acting in the horizontal direction. So of course this component should also be equal to that 50 kilonewton in order to be equilibrium. So FBD sine 45 should be equal to 15 kilonewton. So FBD is 21.21 kilonewton. Similarly, FAD, what is FAD? FAD is the cos component of FBD, right? So FAD is FBD cos 45. I already know 21.21 as FBD. From there I get FAD, the force of the truss or member AD as 50 kilonewton and FBD as 21.21 kilonewton. Next, consider point B. So what at point B is, we already know that's a angle of 45 degree, right? So if I assume an angle of FBC sine 45, FBC sine 45 will be in downward direction, right? If I FBC cos 45, it will be in the horizontal part, and FBC sine 45 in downward direction, you know the component, right? So that FBC sine 45 should be equal to, because I am taking only that FBC, not whole, so that only the small part, and should, if it has to be in equilibrium, that FBC so cos sine 45 component should be equal to that 10 kilonewton force downward. So FBC sine 45 should be equal to that 10 kilonewton. So from that I get FBC as 40.14 kilonewton. Similarly I can find FAB cos 45, that is FAB is simply FBC cos 45, right? So it is 10 kilonewton as FAB. So finally at point A, so point A is if I take point A, we know there is an FAC cos 45. If I take FAC cos 45, we know that angle is 45 degrees, so FAC cos 45 will be in simply downward direction, right? FAC cos downward direction, and the same direction we have the force. So that 20 Newton should be the sum of FAC cos 45 and FAD. Why? Because not to be equilibrium, that the sum of the two values should be equal to 20. Okay, just like we take at the other 2 points. This is a way of solving problem by method of joints. Okay, this way of equating the actual force with a component is method of joints. So we have to know this principle and this idea in order to solve this problem. So to solve this problem of trusses, we have to apply this principle.